Hi, I'm Joseph.
And I'm Addison.
We're here at the Turkana Basin Institute, a partner research facility with Stony Brook University. As part of the Global Innovation Study Abroad program, students aim to improve developing communities while keeping in mind their culture and environment. The Turkana Basin Institute in Ileret, Kenya is housing this program. The facility is integral to the local community and supports anthropology studies. Founded by Richard Leakey, the facility has an emphasis on sustainability.
In the back are water jugs that are fed by a borehole. Right here is where cement blocks and ceiling tiles are made. The cement blocks are cured in the building for a week, while ceiling tiles cure in a pit. Over here to the right, a wind turbine can be seen, which demonstrates TBI's emphasis on clean energy. That is also clear on the many solar panels on the buildings on site.
Right now we're coming up to a reverse osmosis system, which we can see on our left. The tanks we're seeing hold purified water. This is a sustainable way to purify the water on campus. To the left you can see the dormitories where the students will sleep during their stay. Now we're heading towards the dining hall. Here we have a lovely view of Lake Turkana. And now it's time to take a look at our project.
Wastewater management is essential to any community's health. The waste at the Ileret Health Clinic we're about to see is released just above ground level, as you can see right here. This keeps biological contaminants active and can cause the health of the public to be at risk. Conditions can be seen at any of the three buildings. This is the maternity ward right here. The previous building was the main health center, and the other building is the food storage building. Next to these effluent pipes from the sink, you can see a little hole. This is where laundry is washed and drained out of, as well as the shower.
Here you can see the drainage hole from the inside of the building. This is the first sink. It has a hose connected to it, and as you can see, there is no proper piping to irrigate the water outside of the building. The hose is used to fill the laundry bucket. Here is the shower. Because of improper irrigation of the sink, a divot needed to be created in the shower basin to allow water to flow. As you can see here, water from the shower splashes around the room, causing erosion on the bottom of the wall.
Similar sink conditions can be seen here. We have a few spare parts we gathered from 5 other sinks in the facilities, but when we came here there was no plumbing. It's very important because this is the delivery room. For that reason, we decided to focus on this building and help manage its wastewater. As mentioned, resources are limited, and we are developing a low-maintenance, low-energy wastewater management system for these facilities. Here are 2 simple schematics of our plans, and it is now time to implement them. We were able to salvage one backflow from the health clinic, but the other one was too broken, so we asked the Turkana Basin Institute for help, and they provided us with another one. All the materials used through the video taken from scrap material at Turkana Basin Institute, or if they had any tubing or pipes to spare, we also asked and were able to utilize that. A lot of the work that was more technically demanding, such as welding or cutting of metal, was done by staff locally here at Turkana, as you can see right here. Anything else, such as cutting pipes down the sides from the tubes, perforating pipes like you see right here, or anything of that nature, was done by students of the program.
Of course I've washed my hands. Oh, that was on video. That's unfortunate. Oh gosh. I'm sorry. It was a question. I apologize.
Safely walk to school without a sound. Here we are, no one else. We walk to school all by ourselves. There's dirt on our uniforms from chasing all the ants and worms. We clean up and now it's time to learn.
And I miss you, and I miss you, and now I wonder if I could fall into the sky.
Clean up and now it's time to learn.
Oh wow! Oh wow! Oh wow! Oh wow! Oh wow!
As you can see, compaction was very important to keep the structure stable. The structure was laid with the pipes declining into the two barrels, which percolated into the ground. This kept the system fed by gravity. No energy was required to pump anything. To also stabilize the system, as you just saw, a wire was used to hold everything together. It was run through the pipes and through the barrels to ensure that the connections were not lost after the system settled over time.
Teacher thinks that I sound funny, but she likes the way you sing. Tonight I'll dream while I'm in bed when silly thoughts.
Hi, I'm Joseph.
And I'm Addison.
We wanted to express the importance of open sourcing the information we just showed you. We know it's very, very hard to travel to these developing communities, and it's not easy for everyone to see what the conditions are. By making what we saw here into a video, we hope we can get feedback and show people who aren't sure what these developing communities look like, what the real conditions are.
And we also just wanted to stress we are in no way professionals on wastewater management. As you can see, we had limited resources and made the best of what we had available. If you have any other ways we can approach the problem or design this system and maybe implement this somewhere else in Ileret, somewhere else in Kenya, or even another country in Africa or elsewhere, please feel free to let us know. Thanks for watching, and we hope to hear from you.
Thank you.